if you just do it, it'll turn out okay. And today we're here to talk about the non-amniotic tetrapods.
Yes.
They're a neat group.
Yeah, it's unfortunate because they are, even though they are a very neat group, they are often ignored. Especially when you talk about tetrapods, most people talk about reptiles, birds, mammals, and such, but the amphibians get often ignored. So that's why we are here today.
Yes, of course. There's another brand that we're not talking about today, and we're talking about the amphibian brand or the whole brand is called the Batrachmorpha.
Oh yeah, we will get to that. We will get to that. I will start the presentation in a minute. There we go. So, amphibians, two ways of life. So the first thing we need to establish is exactly what is an amphibian, and there are two common usages for this word. Like you can say, and something has an amphibious lifestyle, like it lives both in water and on dry land. And by that definition, many things are amphibious, like crocodiles are amphibious. Some vehicles can also be amphibious, but in this context, we need to be more specific. Amphibians refers to a group of organisms. Specifically, they are. Oh,
go back real fast.
Oh, sorry. Yes.
Just like a crocodile is a carnivore, but it's not a carnivore group.
Exactly. Like it's the difference between a carnivore and a carnivoran. A carnivoran is a member of the order Carnivora, and a carnivore is something that eats meat. Yeah, exactly. So amphibians are part of the vertebrate group, and for that we have many different groups that you can see here. I gave them some names and also like the estimated species number to give some context.
Yeah. And if you want to see a prequel to this event, go check out my discussion with Walker over there, and in the we are can't pronounce the word, but the S word.
Sarcopterygii.
Yes.
Yeah.
Exactly. Right. Just to summarize, vertebrata is characterized by having vertebrae, of course. Also, they have also a specialized head with sensory organs, a heart, and hemoglobin in the blood cells. And a specific subset of that is Neutostomata, which is the subset of vertebrates that have jaws and also dorsal fins.
Of course, there may be one. I'm not sure about this. I read about this. There may be a one branch in between them, and that would be the placoderm branch.
Right. The placoderms are like although it turns out that the placoderms are like a paraphyletic group, which also includes us, but like in a way we are descendants of placoderms. So yes, it's also that's a different thing. We need to move on, otherwise we will be it for way too long. The next subset is Osteichthyes, which is the bony vertebrates, and they are characterized by having, as its name suggests, having bony plates. Like they also have, among other things, lungs. Lungs are actually very primitive, and many fish have modified the lungs to become swim bladders. So yeah, and there are also other things about this, but I will skip to those details. Like for example, you have the skull is actually a mismatch of different parts, but I will skip for that now.
Yeah, and I think they used to think the other way around for a long time. They used to think the swim bladder became the lung. Now they think the lung became the swim bladder.
Exactly. Yeah. I think it was Darwin who hypothesized that lungs came from swim bladders, but it turns out it was the other way around. Swim bladders evolved from lungs. Lungs are the primitive condition. And the next group is the Sarcopterygii, the lobe finfish, and these are characterized by having a lobe fin, which is monobasal. The base of the fin is made of one single bone, the beginnings of a humerus or a femur. And next group is Rhipidistria. This is the group that includes the lungfish and tetrapods. Lungfish are our closest fishy relatives, and we share the trait of having an autostyly jaw. Basically, the jaw is supported by only the mandibular arch. Or maybe can you see my cursor? I think so. I think you can, right?
Yeah, we can see it.
Yes.
All right. Maybe I can have a laser pointer. Let's see. There we go. Like the lungfish and top pods are their jaw are supported by only a single connection with the skull. Like for example, in most cartilaginous fishes, like sharks, their jaw is supported by the hyomandibular arch, as you can see here. And in most ray fin fish, there is a dual connection. And here is another interesting thing. This hyomandibular arch, this right here, those become, I think, the stapes, if I'm not mistaken, the inner ear bone. And then further up, we have the tetrapods, which are those that have like a fully developed limbs, like an ulna, a radius, and also digits. And then, of course, we have the amniotes, those tetrapods with an amniotic sac and then an eggshell. But we are not talking about those. We are talking about. And then we have the amniotes. Oh, I hear echo from somebody.
Yeah, that was me. I thought my volume was down.
That's fine. But now we were talking about the amphibians. But now we have another problem. The usage of amphibians in taxonomy is rather confusing because there are 3 total different usages. Now there is the crown group, which is more specifically called Lis amphibia, which is basically the last common ancestor of all living amphibians plus all its descendants.
Yeah, but there are a lot more that aren't living anymore.
Exactly. So those are included in the total of the pan group, which is the Batrachomorpha. That's what you mentioned before. The Batrachomorphs are the total, more inclusive group. But there's another usage of amphibians, which also includes some of the primitive tetrapods, and also some of the primitive amniote relatives as well. And we will talk about those.
Yeah, the reptilomorphs that could be on land longer, but not their eggs couldn't.
Yeah.
Did you say something, Welker?
Oh, I was just saying yes.
All right. Feel free to make any comments when I go.
Okay.
All right. So now we come to the Lis amphibia, the crown group relatives. So we have. Hold on. Let's see here. I need to move my slide a bit. There you go. They are characterized by specifically by their development. They undergo metamorphosis. Their reproduction is highly dependent on water. They produce larvae with gills, and they grow up into adults with lungs. Although there are exceptions, we will get to those. And when they undergo metamorphosis, they often undergo a dramatic niche shift. They go from aquatic to terrestrial, and often their diet changes as well. And some of the anatomy and physiology includes a highly permeable skin, lacking keratin and scales, mucus. They also often have mucus and granular poison glands. They breathe by buccal pumping. Basically, they pump by moving their throats up and down to ventilate their lungs. They cannot expand their ribs like we do, basically. Their lungs are also pretty underdeveloped in a way because they have a low surface area within their lungs. Our lungs have a huge surface area. They also, and to compensate for this, they also have cutaneous respiration. They breathe through their skin, which is why they have very permeable skin to begin with. That also makes them very vulnerable to environmental changes because of this highly permeable skin. And furthermore, they are also often very loud, especially the frogs. And another thing they also have is that's the next thing. They have pterygoid vacuities, basically these two big holes on the basically this also includes the eye sockets, but they also have big holes on the roof of their mouth, and through these holes their eyes can sink through them, as you can see in this frog right here.
Cool.
Yes, and this also aids this eye movement aids them in swallowing. So when a frog swallows something, they will blink like this, just to push the food into them into the throat.
With the back of their eyes.
Yeah, with the eyes. Yes.
That's pretty funny.
Yeah. And to discuss the groups, they have three main groups: the apoda, the Thessalians, which includes about 200 species.
The ones that lost
salamander.
the ones that lost their legs.
Yeah, exactly. The Eurodiles, the salamanders, about 700, and of course the big group, the Anura frogs. And here I also include some of the total group of each. Like the salamanders are included in a larger group called Chordata, and Anura, the frogs, are included in a larger group called Talentia, and both are included in a more inclusive group, the Trachea. They are each other's closest relatives, and also with the Thessalians, they are included in Gymnophiona. Although some researchers are a bit confusing. Some researchers swap these terms between each other, like they put Gymnophiona here and Apoda here. So it's but most use it in this sense. I'm showing.
Is that like a taxonomic debate based on when those words were first used or something? Or?
I think like the terms wasn't really standardized. Some kept using one word in another way and some in another way. So it's now like what do we do now?
Yeah,
it's really confusing. Yeah, but I think
so.
Well, I think most are using it this way. Yeah.
So this group, and you're talking about this later on, but it comes around probably late Devonian, early Carboniferous.
Oh, we will get to that. See here. Oh, I will go over the different groups of each of the order. Each order, also starting with frogs. Frogs are the most diverse group of amphibians, living ones at least. They are highly widespread, and they have a distinctive body plan for leaping, and for distinctive body plan for leaping, and have although unfortunately they are very many species are threatened. Like over 1/3 of all species are threatened with extinction, which is a really like when a diverse order like this is 1/3 of it is threatened. It's really it's really a very vulnerable group, to say the least. And now they are characterized by a Euro style. Basically, this structure right here in the pelvis, this allows them to jump. This structure right there. They also have a very, very short spine, 9 vertebrae max. Most are even fewer vertebrae. They also have a fused radius and typo, a radio and ulna. They also have a tibiofibula, also fused. Like this bone here is fused, and also this bone here is fused. So it's kind of like birds. Basically, birds evolved to fly. They fuse many different bones together because that's a more economical way to support you. You need a lot of support to fly. And frogs also have a similar problem when leaping. They need to fuse some bones together to be able to withstand the impacts of jumping. Yeah. They also have like elongated ankle bones. They have very big feet, and there are frogs don't have teeth on the lower jaw. It's one singular exception in one species. So here are the groups of frogs. There are 3 traditional groups: the Archaeopetrachia and Paraphyletic species, which are these guys right here. You have also Mesopetrachia, which is this guy right there, or this paraphyletic group right here. And you also have a clade of Neopetrachia, the new frogs, so to speak, which is the huge group right here.
Quick question.
Oh, sorry, go ahead.
Oh, yeah. I'm just wondering, like, so you said that only one species of frog has teeth on the bottom jaw.
Yeah.
Is this like a readaptation, or are they like are they the outgroup to the rest of frogs?
I think not these, like I'm showing here the primitive ones of your example of the primitive ones, but none of these have teeth. So I think it's like a readaptation probably, because it's I think it's one of these guys that have these teeth, or I don't remember. I will get. I think I included the. I think I included the example of this frog later on.
Okay, cool.
Yeah.
I was just wondering.
All right. So these primitive frogs are they have a very strange characteristics to other frogs. Like they have the max number of vertebrae still of 9. Some belly flop the landing. Well, most frogs don't belly flop. They land on their feet, and these guys don't. And they also have tail vertebrae still. But, no, hold on. I know the tail that you see here is the extension of a male cloaca used in internal fertilization. So probably not a primitive condition is trait. So even though they are primitive frogs, some of the traits they have are not primitive. Just to remember. Yeah. And the next group
They
is the
lost their tails like we did.
Yeah, exactly. The next primitive is the Mesopetrachia. Here are some examples: goose frogs, parsley frogs, and so on. Oh, there's another interesting one. This frog here is a highly aquatic one. One species is famous for embedding its eggs inside its skin. So basically, when it's fertilized, the eggs are put inside the skin by the male, and they hatch inside the skin, and then it will crawl out the skin like that. Really bizarre. So yeah. Or even one if in Neopetrachia, that's a huge group right here. Neopetrachia, you have one species, or I think one family of 7 species that are sisters to all the other ones. This is the ghost frog from South America, or Africa, sorry. And then the next group you will see is the Australopetrachia. As the name says, they are mostly restricted to the southern continents. We have one from Chile and 2 from Australia.
So,
and
the Australian ones, did they come there on their own migration, or did we bring them there?
I think they were native. I think they are native. Yes. At least these ones are native. Yes. Yes.
Mm-hmm.
These are the native frogs of Australia. So there are some we introduced, but yeah, so that's not a good thing. But let's see. I want to mention these frogs here. This family includes the gastric brooding frogs. They swallow their youngs until metamorphosis, but basically they will keep the frogs inside their stomach, I think. Although they became extinct in the 80s. And you also have another species are called the male pouch fox. They guard their eggs and carry the tadpoles inside pouches until they metamorphose. Yeah. So moving on. Next group here is the Hyloideae, and it contains 3 families. There's also the Darwin's frog, or mouth-breathing frog. They carry the tadpoles inside their vocal sacs, not their stomach, not in the previous example, but still something similar. They have a very extensive parental care.
So almost like the seahorses of the frog world.
Yeah, basically. Although I don't think the seahorse also has like a nutrient exchange within their pouches, but I don't know about these guys. I don't know. I think it's just more of a protective behavior by carrying them in their mouth. Yeah. And you have also like a few other fox families here. And the next group is the sorry. Yeah, next few families of this Hyloideae group is this family and this family here. Oh, here here you have the marsupial frogs, which enclose their eggs in a pouch. This is more of the frog you described previously. They enclose the eggs in a pouch. And oxygen is provided by the vascular tissue right there.
Do they like erupt out from the back, or is it?
I'm not sure. I think they carry the eggs on the back, hatching as tadpoles or as fully developed froglets, skipping metamorphosis even sometimes.
So like,
and some froglets stay on the back.
So they're almost like the amniotic frog, not amniotic, but they like skipping the fish part, going straight to the four-legged part.
Mm-hmm. Yeah, you have some frogs like many times you have direct development, like when they hatch as froglets when they skip metamorphosis. It's the metamorphosis basically occurs inside the egg itself. Yeah, and you have also this bizarre family of horned frogs. Like I like to call them Jabba the Hutt frogs because I don't recommend this, but when you can look up YouTube videos when they devour things like mice, it's pretty horrifying, really. So don't
That's
look
the
it
family
up.
that includes like Pac-Man frogs and stuff, right?
Yeah, exactly.
So are these like?
They're also called Pac-Man frogs, yeah.
Yeah. Are they? Is this like the bullfrog family?
No, I don't think so. No.
Okay.
Have you ever seen Pac-Man frogs or Pixie frogs at like pet stores?
No, I don't think so. Pet store. No.
Oh, okay, well, they're pretty common, but I was asking Vidalia just for reference.
But no, I haven't been in a pet store in a while.
Fair.
Unfortunately.
All right, the next families are here. Do you have another crazy family? Basically, you have like one frog also direct development. You can see here the froglets just inside the egg and hatching. And you also have another species that has ovovivipary. Basically, the eggs are inside. These are the rubber frogs. All have direct development, hatching as froglets, no tadpoles. Some are oviparous. One species laying eggs ready to hatch, and one species may have given birth live to froglets. Although this is a question because it's possibly extinct, this one species. So it's an open question. So yeah, and another related family includes the dart frogs. Like here, there's there's a superfamily here and two families here, and one is the cryptic poison frogs, and then another is the poison dart frogs. And they are all some include from the extremely toxic frogs that you can find, and it's often accompanied by aposematic coloration, like the blow dart poison frog. Although they are not innately poisonous, they are poisonous from their diet. They get the poison from the diet, basically. Mm-hmm. And then another group here is basically the most common frog you can find out there. Like they are tree frogs, although many don't live in trees, even though they are called tree frogs. Mm-hmm. And another few families here. You have another one group that includes species that lay eggs in foam nests, where the tadpoles remain until metamorphosis. And here you have the Buffondae, the true toads. There are lots of other frogs that are called toads, but this family is the true toads. Mm-hmm. They are widespread around the world, although they are invasive in Australia. They are not native to Australia, but they are invasive there and causing really big problems. They are all toads are all toothless. Most lay eggs in strings, and they also possess a pair of glands that secrete toxins, like on the sides of their heads. You can see these glands. And a few hatch as froglets. Some of them also skip development or metamorphosis. And then we have another few families right there. Another interesting one is like a glass frogs. They are pretty much transparent except for their organs. Like you can see, this is a very neat picture. taken right there. You can see basically inside of the frogs.
Is this like the most populous clade, or at least most species?
I think so. Yeah. I think this is like one. Like I'm now just scrolling through this group right here. So yeah.
Will they shatter if you drop them?
The glass.
No, I hope not. I wouldn't try.
I don't know if anyone's tested it. You might have to be the first.
Yeah, it probably has to do with like camouflage. I think like when they are on leaves, the translucence like masks their outlining, so they will basically like more blend into their environment. Yeah, it's probably a camouflage thing. So moving on, now we get to this group right here. This group here is called the Zooglossidea, and they include these four.
Oh no, I was just laughing at the Seychelles Island frog or whatever that one is down there, or the purple frog of India.
Yeah, it's a really bizarre group. Like you have this Zooglossidea group. It includes the Zooglossidea, the upper four. This example, includes 4 species, and I think they are these group are native to Madagascar, and this group is native to India. This one right here, and if you remember your plate tectonics, India and Madagascar used to be connected to each other. So the thinking is that these groups basically evolved on the same when these continents of these islands were connected, Madagascar and India, and when they departed from each other, you have this group in Madagascar and this one in India, and yeah, this one is really a bizarre looking frog. Yeah.
Interesting. So I'm just looking at the phylogeny, and I'm assuming that red line is the KPG extinction, right? And it's talking about like adaptive radiation after the KPG. So didn't the islands of India India's not an island anymore, but at the time, didn't the islands of India and Madagascar split before the KPG? Or am I wrong there?
I don't remember. Maybe you're right. Maybe yeah.
So, oh no, I'm just wondering. I mean, it could have been like a secondary.
It could be the case that they were like more closer together, and then that allows for more like dispersals events between the Madagascar and India.
And also the models are typically a bit more sensitive to picking up adaptive radiations that don't exist than missing adaptive radiations. Yeah.
Okay. If that's the line for the KPG extinction, then where's the line for the big one, the Permian extinction?
It's back here. It's back here. Like frogs are like they begin in the Triassic. Frogs.
Okay. Yeah. So they got that diversity died a long time ago then.
Or maybe frogs are a product of that diversification event.
Yeah. Exactly. Yeah.
Yeah.
No. There's also this family right here. This is the Microhelidae. They include I think the smallest vertebrates that are known so far.
Oh, and also, so this picture right here, these are all just the current living frogs, right?
Well, exactly. The currently, like I will mention some notable fossil examples.
Okay. All right.
And then the next few families here, you have the rain frogs. Like this is one pretty famous one. You have like a video, I think from BBC or something. You have like a narrator, really fun, very humorously narrating this frog as a voracious frog. It's really funny if you look it up. The desert rain frog, if you want to look it up.
Yeah. I've seen that, and it has like a little squeaky sound.
It's really squeaky sound. Yeah, it sounds like a dog toy. That's the narrator.
So I don't know if you get to it or not, but question. Thought something. Are all amphibians, mostly frogs too, are they all carnivores or are some of them herbivores?
I think they are pretty much all carnivores. Yeah. I think I don't remember. I don't know of any amphibian, even outside frogs, that has that includes like plants in the diet. I don't know of any.
Okay.
No. All right. So another notable example here in this family. This family includes the what's called the wolverine frog. Also the hairy frog, because it has like it doesn't really have hair. It has like fibers or maybe extension of its skin to increase its surface area. But it's also called the wolverine frog because it's when it doesn't have claws, but it can use its internal bones inside its hands as claws. But when it does that, it breaks its own bones.
Mm.
And now you know why it's called the wolverine frog.
Wow.
If you know the Marvel character.
That's terrifying.
It's really bizarre.
So it can heal. It can heal its own wounds.
It probably has to if it wants to heal. It's when it retracts its bone claws again, it has to heal itself. Yeah, every time. Exactly. Alright, moving on. You have also these examples of frogs, and then the final group is the Natatanura, if I pronounce correctly. And you have many different families, and this one includes the largest frog known from Africa. And then you have also these frogs right here. You have the old world of the flying frogs. That are really elegant leapers from tree to tree.
And if I'm not mistaken, bullfrogs are in Rainidae, right? Or Ranidae? The one on the bottom?
I think so, yeah. These are, I think, also a very common frog that you can find in your backyard, I think.
I was just saying that because Vandalia was asking about it earlier.
Yeah. So these are the true frogs?
Yeah, and you have like a family of true frogs,
Yeah. A lot of the naming is kind of...
Get out there, all you other frogs. These are the true frogs.
Yeah.
Fake frogs.
Right. And also something about the about the biogeography. Frogs' biogeography reveals that they ended up on different continents in concert with the continental drift. Over 88% of frogs originated from three lineages that diverged after the KPG extinction event 66 million years ago. Like you can also see here. Here's on the three, like these three big groups right there. The green ones, the purple ones, and the blue ones. Like have a big radiation after the extinction event. And also notice that the arboreal lifestyle evolved multiple times independently. They are called green right there. Here, like here and there. And you can also see here. I think this is the group with the I mentioned the very bizarre purple frog and the one from Madagascar. You can see here that they link it with the continental drift between India and Madagascar right there. Yeah. Alright, so some of the fossil frogs and their relatives. This is probably one of the most famous extinct fossil frog known. And also a very well named one. It's called Beelzebufo, the devil's toad. Quite literally, it's really a good name.
Madagascar.
Yeah, it's from Madagascar 70 million years ago. And the recent study, like they look superficially like the Pac-Man frogs or the what I call the Jabba the Hutt frog, the very big mouth and such. And indeed, the recent study links them to the South American common horned frogs. Although a problem with that is like these are from South America, yet this one is from Madagascar. So either a very rare dispersal event happened, or this study is wrong. So it's still a bit of debate about that. Also, one thing is, if you've seen the recent documentary Prehistoric Planet with the very well done CGI effects of the dinosaurs.
I have not seen that one yet.
It's pretty good.
Like in one episode, you have Beelzebufo doing a cameo there, like swallowing a dinosaur, a hatchling.
Oh, it's like a baby T-Rex, right? Yeah.
I think so. No, it's not the T-Rex. Like another theropod. I think it swallows up another theropod. Yeah.
Okay. Yeah, I think I remember that scene.
Yeah. And now you have like a very primitive extinct frog right there, like a transitional frog. It is the Triadopatracheus from the early Triassic, also from Madagascar, and it has some traits that frogs nowadays lack. It still has a tail vertebrae, separate tail vertebrae. doesn't have a complete Euro style yet, so it may not be able to jump, at least not like mother frogs do, and it also has many vertebrae, and whereas most modern frogs have few. So it's a transitional species of what frogs started out with. And you can also use some figures of
So
how
these are the ones that came out.
Oh.
So these are the frogs that survived or came after the Great Dying Extinction, the Permian.
Like we don't have any frogs, or at least stem. I don't think we have stem frogs from the Permian or earlier. Like the earliest frogs or stem frogs are all from the Triassic, so after the extinction event. Yeah. So now we move on to the salamanders. They are plesiomorphic, or primitive in a sense, in contrast to the highly derived frogs and crustaceans. But nevertheless, they exhibit a very great variety of body plans and lifestyles. And they also include the largest amphibians alive today. And they have also various developmental trajectories, including very different breeding strategies. Some are known to be highly toxic, in concert with episematism as well. Although, again, over half of all species are threatened with extinction, unfortunately. So moving with going over the groups, it's like one half of salamanders is the Cryptopranchoideae. These are the old group in a way. Like they include the Asiatic salamanders and also the giant salamanders.
So did these guys not come till after the Permian, or before the Permian?
I think you can see the time scale. They're also Mesozoic. They also don't go back to the Permian. I think the same with frogs. So basically, okay. yeah. So you have the crypto, the giant salamanders. They are fully aquatic, and they use the frills on the sides of their bodies as gills. Basically, they don't. Mm-hmm. I think they may breathe air. I don't know if they breathe air. Maybe they don't.
I think they might need to supplement air, but like I don't think that they can get enough through their skin. I know the biggest ones have to live in like super fast moving water, because they have to constantly refresh the oxygenation. Even the American species, like the hellbenders that live in the US,
you have the hellbender.
Yeah, they still have to live in pretty fast moving streams for the most part.
Mm-hmm. Yeah, it's do you know if they breathe air or maybe gulp air sometimes? I don't know.
I don't know. I would assume it's likely, but I don't know.
And they are often also very slow moving and very inactive comparatively, because they have to compensate with their metabolism. They can't have a high metabolism if they don't get enough oxygen like they do. But yeah. This also makes them very vulnerable as well, and they're also really restrictive and very difficult to find. Like most of them live in like Asia, I think, right? Japan, China, and also one, as you mentioned, the hellbender in the US. Yeah. And then moving on to the big salamander group, the Salamandroidea. They include these guys, the sirens, which have these are neonitic. They have incomplete development. So basically, they only develop the front limbs, but they have no hind limbs, and they also retain the gills as adults.
So they're more completely aquatic. They're not. They didn't go to the land at all, probably.
Mm-hmm. Yeah, although different from this phylogeny, this group may be actually sister to the rest of the salamandroids, and also these guys, the hold on, I need to rethink from internationalization. Like I made notes on my slides and I don't remember all of them. So.
I know you're chill. I mean, it's impressive that you put together this much of a presentation. It's very in-depth.
I had a long time, so yeah.
Fair.
Internationalization. If I remember correctly, these So, I don't remember exactly, but like one group has internal fertilization and the other group does not have internal fertilization. I think like they may form a separate group to also mandroids, which have internal fertilization, female storing sperm into opposite. I think this group has internal fertilization, unlike the crypto branchoids. Yeah, I think so. All right. So now we have the another group called the Amphiumas, another neonitic salamander group with they retain gills, they have long bodies and reduced limbs, and they also have like very reduced eyes. Apparently, some of them. I think they may live in caves or something. Yeah.
Yeah, like a little derpy way.
Yeah. It looks like a Muppet.
Yeah. Tiny legs.
And now another neonitic salamander group. You have the olms from the caves of Europe, and another the mud puppies or water dogs from the North America. But it's a common theme that they retain gills and have incomplete metamorphosis. And now we have this family here from the US. They are the torrent or cascade salamanders. And another very interesting family is the Plethysodontidae, of like over 400 species. They are the lungless salamanders. They have no lungs, no gills. They only breathe through the skin and vascular tissues inside their mouth. The eggs hatch as fully formed adults, so they also skip metamorphosis. And this allows them to spread to terrestrial habitat. So they're pretty much completely disconnected from bodies of water. And because they only breathe through their skin, they compensate this by having low metabolism. They also have like model size. They are very small, and they eat prey, very tiny prey such as springtails, often with like a projectile tongue. And this makes them very successful. Even though this is a very diminutive strategy, they are very highly successful. Some species dominate the vertebrate biomass with populations over 2 billion individuals. Really impressive. Although, despite the success, many are threatened and one is extinct, probably due to their strict reliance on skin respiration.
There's a lot of cool plethodontid diversity in the Appalachian Mountains because, like as the populations during the Ice Age, these guys are mostly cold adaptive. So during the Ice Age, they were able to, diversify across a lot of different mountains and stuff. But as the glaciers receded and the climate got warmer and stuff, they sort of got trapped on mountaintops. And so there's like a lot of cool, I don't know, like speciation patterns related to that.
Yeah. So amphibians and frogs can survive in cold atmospheres.
A lot of amphibians, I mean, obviously it varies by species, but a lot of amphibians are better at adapting to cold weather than reptiles are.
All right. So the next group we are looking at, the next family, is the Salamandridae from North America, Europe, and Asia. The true salamanders, also another name convention. They also include the Pleurodelinae, also called the newts. They are characterized by rough skin due to the numerous poison glands. Nearly all produce potent toxins. Some are extremely deadly. The genus Taricha, the rough-skinned newt, produces tetrodotoxin, the most toxic non-protein known we know of. And it's the same with pufferfish. Pufferfish also produce tetrodotoxin, and both the pufferfish and this newt get this toxin from symbiotic bacteria living inside their skin. Although I think in the pufferfish case they live inside the various tissues, but in the newt, these bacteria live in the skin, and that's how they produce this toxin. They also have a co-evolutionary arms race with the garter snakes with TTwC resistance. Some of these salamanders give birth to live young, no tadpoles, and some are neonitic too.
Okay, so they're getting poisoned out, and the snakes are trying to eat them, and they're trying to think, "Oh, I'm more poisoned now. Well, no, I'm more resistant to poisons. I can eat you now." Like, well, no, you're not.
Yeah. You also have this defense reaction. Basically, if you handle or touch a newt, sometimes it will do this, showing its underside bright yellow. Basically a warning. Like, you really don't want to eat me. Trust me, you do not want to eat me. And then, although again, I think I found this very neat picture, but it appears that sometimes it's a bit outdated because some researchers found that these two genera are more closely related than it is shown in this graph. But still, this includes the family Ambystomatidae, which includes the Pacific giant salamanders and also the mole salamanders. Basically, the largest terrestrial salamanders are, of course, the giant salamanders that we previously mentioned are all aquatic, but these are the ones that are the largest living on land. They also include the tiger salamander, and also the tiger salamander is facultatively pedomorphic. It sometimes complete its development as adults, but sometimes it can go into something like this or not. And this plateau tiger salamander is similarly facultative pedomorphic, and they have the actual another closely related member, which is completely pedomorphic. It doesn't complete its development into adulthood. It retains the gills.
And they're endangered.
Also critically endangered. About only 50 to 1,000 wild individuals left. Yeah.
That's specifically in the wild axolotl populations. It's a model organism for science, and so there's like thousands, potentially hundreds of thousands in captivity, being raised all the time. But it's just because they live in Lake Tenochtitlan. Well, Tenochtitlan was the capital. Is it Lake Titicaca? I don't remember, but it's the lake that basically Mexico City was built in.
I think so.
Yeah. That's where they're native to. And so, as you know, Tenochtitlan was the capital of the Aztec Empire that was built on an island in the middle of that lake. And then that city eventually grew out a little bit, like onto mostly floating rafts. But then recently, a lot of that lake has been drained and filled in to make way for Mexico City. And now there's just not any axolotls left there. Texacoca. Thank you.
I think I forgot to mention the frog that still has his teeth. Like I think I could include it in the slides, but should I go back, or do you think we can move on? Maybe
I can just look it up.
Yeah, right.
We can do that. We can put that in the bonus section.
yeah, sure.
Next to our live stream, just for that frog.
All right. So now I know some of the fossil salamanders. This is a recent from 2021. This is a recent find. So I think it's a close relative of the. This group here is the giant salamanders, and this is the Asiatic salamander. So it's like a close relative to them. And I've written here to be sure. The giant salamander group have external fertilization, and the salamanders like the newts and the axolotl, which belongs here, they all have internal fertilization. So I remember it correctly. Yeah. And now we have also some stem members of salamanders. You have this one, Carus and Cocartus, and also recently Triasaurus from the late Jurassic was described as the oldest stem salamander in 2020. And you have also another one from this year, 2022, Mammuroperton from the Middle Jurassic. All right, so now we get to these a very interesting group, the Thessalians.
That looks horrifying with its mouth open.
Yeah, horrifying, exactly. They are very unusual and highly derived amphibians to the point of looking more like earthworms or snakes.
So these are, but these are like the amphibian versions of the snakes, like the tetrapods that are no longer tetrapods.
Yeah, it turns out that the snake body plan evolved many times. Like even within among reptiles, or specifically the lizards also many times. Yeah, and we like even this group we used to think they were actually related to snakes.
Really?
Because I don't know when we found out about the affinity to other amphibians, but I don't know. Maybe you can look it up later. Yeah. They are characterized by long, slender bodies, loss of limbs, reduced vision. Sometimes they don't have any eyes, I think, some species. They have tentacles on their face for smelling. You can see this one here. They also have very robust, pointed skulls, wherein the bones are fused, capable of forcing their way through the soil with their heads. And they also have like one lung. Like our lungs come in pairs, but in salients and also in snakes, they only have one lung as an adaptation to this slender body plan. And all have internal fertilization, and they copulate for like 2 to 3 hours. So it must be a very fun life for them. And they also have like a very bizarre trait. They also have calcite scales. They are unrelated to fish scales or lizard scales. So they have their own type of scales. And now we have like some of the groups of Thessalians. You have this group here, the two basal, two primitive, or two early diverging groups.
And these again are after the Permian, the Triassic, and afterwards.
Also it's the same story after the Permian extinction event. They show up, or at least some of the relatives show up.
It makes you think, what was before the Permian then?
We will get to that. Yeah. But some of the notable things about these early diverging lineages is that they don't have very ass pointed skulls, they don't have as pointed skulls as the other groups. They also retain some of their tail. Like this group still has the tiny nubbin of the tail, while the rest of all the Thessalians have no tail absent. They only have like a tiny anus at the end of their body, basically. And they also still have metamorphosis. Like most Thessalians don't have metamorphosis, but these guys still have some form of metamorphosis with this. Yeah. And they also have like this group here, like a derived trait within this group is they have 2 sets of jaw muscles. Yeah. I think this trait of this group here is also shared with the rest of the Thessalians. Like this group has only 1 set of jaw muscles, while all these other guys, and also this lineage here, this one, has 2 sets of jaw muscles. Yeah. All right. And now we have like this huge group of Thessalians. They are some of the notable things to mention is like in the figure you can see that whenever A occurs, you have the evolution of obligate aquatic lifestyle. So this group has obligate aquatic lifestyle, as you can see here. When B appears, you have river parody, live birth. You can see here B, so many times. And in these species, cells lining the oviduct feed the young. Also really bizarre. And when C appears in this here, direct development, the re-emergence of metamorphosis, like in the whole group, metamorphosis was lost, but then it re-emerged right here, and then it was lost again right here.
Make up your mind.
So,
Natural
Make
selection.
Up your mind.
You want them or you don't want them.
Yeah, make
up your mind. Yeah. And also one interesting or notable species here, and this above species, an egg-laying species. The female develops a thick, nutrient-rich skin, and the young feed off of it.
So these are like the mammals.
Exactly. It's like to us with milk, but we feed our young sweat, and they feed their young their skin. So yeah, it works either way. All right, some fossil, actually not some, but only one fossil Gymnophionian, one stem Caecilian we know of actually. Like Caecilians have a very poor fossil record. Like I think there are some crown fossil members, but this is the only stem Caecilian we have. It's called Eocaecalia from the early Jurassic. But even though we have one, it is still a very impressive find because this one still has legs, and it also still has like a more typical skull of tetrapods. Like Caecilian skulls are really bizarre, but this one still has a more normal skull you would expect. But yeah.
So where are the crossed out words there on the last page?
Oh, sorry?
Crossed out some and.
Oh, yeah, because there are it's more humorous because I want to include many stem members, but there was only one.
Okay. And again, this is after the Permian.
Yeah, and another thing to mention about amphibians is there is we now have 3 orders of amphibians left, but there was a 4th order called the Allocaudata, including only a single family. The 4th group of amphibians, since they occurred since the Jurassic, and only recently became extinct, some 2.5 million years ago. The affinity of this group remains uncertain. They may be related to the Petragians, the frogs plus salamander group, but not certain. Perhaps they are outside crownless amphibia. They possessed fish-like scales in the skin, and they also may have developed directly into adults without metamorphosis, and they may also have been lungless. And there's another recent find from 2020 from Burmese amber, this species, and it showed that this species fed by a ballistic tongue, like a chameleon, basically.
So if they were lungless, I'm guessing the fossils are quite small.
Yeah, exactly.
Yeah, never mind. I'm thinking never mind. I'm thinking another word. Right, never mind. Go on.
All right. So now we have summarized the crown group of amphibians. So we went over the Caecilians, the frogs, the salamanders, and also a related extinct order. But then the origins of the whole group as a whole is very controversial. So basically, it's with molecular estimates, there are very wide ranges. Like Petrachia may have originated at the end of the Permian, or maybe it's as far back as the Carboniferous, and this amphibian as a whole maybe spans the entire Carboniferous, and it's still a pretty mystery of when and where they originate, and to what they are related to. So, but in order to more understand this, let's go back all the way to the Devonian, where the first plants emerged.
And where we decided to get out of the water.
Yeah, and when fish came out of the water in the late Devonian. Right. So during this time, the land plants caused a major terrestrial transition of ecosystems. They stabilized the soil, which meant that the rivers flowed in deeper and more permanent channels, provided sources of food, safe habitats, and also many animals soon followed. First the arthropods in the Silurian, and then tetrapods in the Devonian, as you can see here. First we have the stem tetrapods, which are included in the more inclusive group, the Tetrapodomorpha. And the prey that unites this the stem tetrapods and all modern tetrapods is the nostrils. Basically, in your skull, you have for each nostril you have 2 openings: the outside opening and the opening inside your throat. But in fish, these openings are both on the outside, like you see the inflow nostril and the outflow nostril. But as during the evolution, the outflow nostril moved inside the mouth, as you can see here. Like in this species, it's right on the edge of the mouth, like a very, very beautiful transitional fossil. It shows this transitional between the nostril, the nasal openings. They also have like two radial elements, the radius, ulna, tibia, and fibula as well, as a uniting trait. All right. And then the next group, next subset of Tetrapodomorpha is the Elpistostegalia. One thing to mention about the deform group is like you have these different lineages. They survive for a very long time, and one of them includes one of the largest, I think the largest freshwater fish to have ever lived, Rhizodus.
So Walker,
I think
sorry, Walker. This is your wheelhouse. This is around your wheelhouse, isn't it?
I mean, this is what I gave a presentation on the other, actually, it was 2.5 years ago now? Yeah, a while ago. But I mean, I'm sure Neslick still probably knows more than me. My true wheelhouse is computational phylogenetics, but yeah.
So
yeah, no, I think early tetrapods are awesome though.
Yeah, they are awesome. If also these Eotetrapodoformes, like some of the early began to be more like tetrapods, like Pendorectes, with like a more flattened head and such. And then if Elpistostegalia, like Pendorectes, if the group Elpistostegalia, which are characterized by clear terrestrial tendencies, flattened skulls, as I said, and also the loss of dorsal and anal fins, and fewer radial elements, like fish, like ravenfish, have many of these bones in their fins. These guys have fewer bones in the ends of their fins, basically. And then we get to the group Stegocephalia, which are as the name suggests, I think so. Stegocephalia means mobile neck, if I'm not mistaken. Their heads are detached from their shoulder girdle, and it's probably this mobile neck is probably meant for feeding on land, because a mobile neck is not really useful in the water, because you can just move your whole body easily around when you want to feed. But on land, having a mobile neck is very, very useful. So, yeah.
To stay there, I'm going to turn around completely. Yeah, or just neck.
Exactly. Like if you want to catch something on land, you have to you probably have to turn around pretty quickly to catch something, and having a mobile neck is pretty handy to have that. Yeah. Otherwise, you have to constantly move your whole body around every time. All right. So now then the subset includes the Tetrapoda, at least in the broad sense. Like there are two senses of tetrapods, like the crown group sense, or a much more broader sense. In the broad sense, it means species that have fully established digits, and the number steadily reduced from 8 digits to 5 when we reach the crown tetrapods. The trend also includes the trend of them also includes the increase of robustness of the pelvic girdle, because of course you want to be able to support yourself on land. And also as I mentioned before, the hyomandibular was reduced and only retained for auditory functions, the stapes. So the bone that I mentioned way before that became the stapes. And this group also still has gills. They still retained their gills. So now we have these. These groups. One thing to mention about this is, like, even though the first tetrapods with digits occurred around this time, we know of tetrapod tracks going all the way back to this timeline. So there is still, even though we have a very fantastic record of transitional fossils, there is still a lot of the history that remains unknown. So we still need to know. We don't need to have new transitional fossils, because we already have a lot of transitional fossils. But we still could learn more about the history from older fossils.
Oh, you hear that? Get out there and get the digging and get the DNA in.
Exactly.
Yeah, exactly.
Yeah. I mean, every new fossil creates 2 new branches on a phylogeny, so that's more places to find more fossils, right?
Oh, yeah, exactly. Yeah.
Yeah, I just wish I know it's impossible. I just wish we could get DNA from fossils to really confirm.
Yeah, that'd be nice. You can with some, but not with anything that's old.
Yeah.
Right.
To really confirm this, that the morphology matches the DNA, because we know for some of animals, once we DNA them, they're like, oh my god, we are totally in the wrong spot there.
Mm-hmm.
Yeah, a lot of that was more due to, well, I don't have to get into the history of phylogeny and systematics, but a lot of that, just briefly, was due to people overweighting certain characteristics. But since we already have DNA phylogeny for like closely related groups, you can sort of use current morphological matrices and sort of like extrapolate those morphological features out to like historical organisms and stuff like that. So it's a little bit easier nowadays than it used to be with morphology, right. I'd say.
Oh, one thing I forgot to mention is like I color coded these bars. If you can see it, like I call these blue if they are primarily aquatic, and these are like more white or striped, so they are like semi-aquatic. But yeah.
Okay, and then the white ones are terrestrial, I'm guessing.
Yeah.
Okay.
At least as best to my own guess. So don't quote me. Do your own research. So this is more my presentation.
Yes.
As best as I could. Yeah.
As they said in the old Reading Rainbow, you want to take our word for it.
Mm-hmm. Right. One thing about the early evolution of tetrapods that sometimes gets ignored is you have much more diversity about the stem tetrapods than just the Ichthyostega and Kenthostega. You have also these guys, which are really, some of these are really bizarre. Like you have some that returned to being primarily aquatic as well. Like this one, Crassia chironus, I think, as I pronounce it correctly. You also have this lineage over here, the Aesopods. They used to be actually classified within ground tetrapods, but now recent study has shown that they have some primitive traits, so they were moved out of the ground group and now they are here, and they have a long lineage. It appears that they have a long lineage of missing fossils right here. They also evolved legless. They lost their legs. So the snake thing was already invented in the Carboniferous, basically. The snake, yeah.
So if that, oh wait, never mind. I thought it went all the way to the present, but the bar graph doesn't.
It ends right there. Sorry, maybe
at like
unclear, but
oh no, you're good. I just wasn't.
So that one ends during the Carboniferous rainforest collapse era.
Yeah, I think they went extinct around in the Permian. Yeah, that's right. Although ground tetrapods continues to on. Maybe I should have made it clear that they were extinct. Yeah. Although I think I will have a.
We can only do so much of the space you have, you know.
Yeah, right. I think I include a more bigger picture later. Like I will move on. You have also something called the Homer's gap. During a time when tetrapod fossils are not as common. Like you can see that these guys cut off right here, and not many are shown here. So yeah, this is another area where we have some gaps to fill, or at least. So again, I do make it clear for the creationists that we still have these fossils, so don't worry about that. But we can still get more history about these guys.
So this is probably during like the gap was probably like maybe during the late Devonian extinction.
Yeah, around the time, yes.
The gap could also just be because like the environments and the ecosystems that they lived in have eroded, and we just don't have those rock like deposits anymore. Yeah, right. It doesn't necessarily mean that like these clades were on the verge of extinction or anything like that.
Mm-hmm.
Okay.
All right. So as you can see, like I basically for the next slide, I squished this whole figure down to this. So now you can see when these guys went extinct. Like some of these guys went way into the Permian. And now you have these crown tetrapods. And they, again, some of the phylogeny is still being debated, but this is the best way I can show everything as of now. You have the temnospondylus, this big group right here. I have also the lipospondylus, big group right here. I covered I cover them in this next slide. The traditional amphibia as a paraphyletic group includes all of these guys, also some of the primitive tetrapods, and these guys, and also some of the early amniote relatives. And then you have like the Ichthyostega, the primitive tetrapods, also in a traditional sense, because these are not clades anymore. Like I'm still using the Linnaean taxonomy just for fun for now.
Okay.
You have also the Anthracosaurs, the reptile-like amphibians, right there, and the temnospondylus. Although temnospondylus are still monophyletic, luckily they are still monophyletic, right? And the lipospondylus also. Yeah.
And the ones on the far left side, that's the one we talked about earlier. These are the ones we're talking about.
Like all the ones in the bottom left corner.
And
no, I meant the top left corner.
Yeah.
And the top left corner, those are the surviving ones, or it's over here.
This one. These are the surviving ones, the crown amniotes.
But they're not amniotes.
I now added an arrow. If there is an arrow, it continues on.
But the amphibians aren't amniotes, are they?
No.
Sorry?
The amphibians aren't amniotes, is what he's saying, and that says crown amniota.
And these are the amniotes. This lineage right there. Although it's outside the you can see the red block.
But I meant
like crown.
Let me rephrase that earlier. The listed
amphibians.
Yeah. Backtrack, yeah.
They're
over here. They're on the left side.
Oh no, I did not include the Batrachia yet.
Okay.
I did not include them yet. I will include them soon enough. The two important groups important when it comes to list amphibian origins are these guys, the temnospondylus. Specifically, you have two groups, the saurophoids. These guys right there. The saurophoids are these guys.
All right.
And you have also the stereospondylus, and then these are these guys, the stereospondylus. And now, of course, the lepospondylus, and these are these guys, the lepospondylus. So first, going over the lepospondylus, the isopods, I'm pretty sure you mentioned the legless group right there, that I mentioned before. They used to be classified in this group, but not anymore. And these include the microsaurs, some tiny amphibians, with slender bodies, some semi-terrestrial, also pretty aquatic. You have also a recent discovery called the Jormungandr, named after the world serpent from Norse legends.
Okay.
And then also one of the most, I think the famous lipospondyl is the Diplocalus, which has this boomerang head. In skeleton, it looks like this, but it probably looks more like this when you have skin all surrounding it all the way around it. Yeah. And another group is these guys, the also pre-snake like group, yeah. And then if it's the temnospondyls, now I'm showing the subgroup of temnospondyls, the saurophoids and kin. And this includes also a famous fossil amphibian, the Platehystrix, the one with a cell in its back, independent of the pelycosaurs, like these synapsids, yeah.
But they did. Everyone was doing that when it was cool. Everyone had the cell back when it was cool.
Yeah, and I think it also lived in the Permian. I think I see here. Yeah, probably lived in the Permian, right there. Yeah. All right. You have also these other guys, and some pretty ferocious predators, although not as ferocious as the stereospondylus. The stereospondylus includes some of the biggest amphibians that ever lived.
The amphibians that could probably eat us.
Yeah, you have Prianosuchus, you have Coelursuchus, and you have also some of the Mastodonsaurus, the largest toilet bowl heads.
That one's huge. I've never seen that
Yeah,
one
yeah.
before.
Yeah.
Yeah,
Yeah.
and they're called toilet bowl heads because their heads can open up like this, like the head can open up like that.
Yeah. So,
like a
so
toilet
if you
bowl, like
if
a
you were
toilet bowl.
back then, so if you were
Mhm.
back then and they were hungry, you wouldn't be anywhere near them.
Exactly.
Probably
They-
not. Do
And also,
paleontologists also think that these guys breathe through their skin? Like
yeah,
modern humans?
I think probably like I've seen some research about Prianosuchus. It shows that their metabolism is similar to fish, so it probably live like a fish, basically breathing through its gills, probably also still gills, and also maybe cutaneous respiration also. Yeah. So this guy probably never left the water either. This Prianosuchus.
Well, so these are that big one, the bomb. They might be like no, they're still have gills, but they might be like the ones that return to the water, maybe like the whales or the ichthyosaurs of the Permian, the amphibians.
They probably.
Really?
I think I don't remember any amphibian that, or even extinct ones that return to the ocean, like because they have permeable skin. They cannot handle salt water basically.
So these are mainly these are the mainly
Freshwater.
freshwater things.
Yeah,
that
exactly.
Yeah.
All right.
Also,
real fast. Also, I heard that I don't know if it's true or not. Years ago, that we used to think that all the tentaspondals were extinct, but now we might think that the current amphibians are tentaspondals.
Hey, no
I
spoilers.
will get to that. Spoilers. I will get to that. But one last thing is about the Mastodonsaurus is that they have lower tusks and they poke through holes in their snout, basically. When the mouth is closed, they will poke through the holes. It's also bizarre. It's like a narwhal. Like narwhals have a tooth that goes through the lip. Although in this guy it's a skull. So one thing to mention is that these are not like modern amphibians. Like respiration and ontogeny were quite different. Like amphibian lungs are inefficient at releasing CO2. They mostly do so via gills and or skin. Or maybe I got it all the way around. Yes. The amphibians release. Hold on. I think I got it wrong. Hold on. It's modern amphibians. They breathe oxygen through the lungs and they release it by their skin. The modern amphibians, but the primitive ones, of the earlier ones, they breathe oxygen in through their lungs and they release the CO2 by their gills. Yes. So most early amphibians retained gills as adults, and they also had fish scales. So the early amphibians, these guys. Although, and early amphibians also did not undergo metamorphosis, and metamorphosis is a more derived trait among the little amphibians. It appears. Like as you can see, and this is I think it's a Prianosuchus, if I'm not mistaken. It still has larvae, but it's not metamorphosis. It's a more gradual way of development. So metamorphosis is more of a derived thing in this amphibian. It appears. Yeah. Also, one thing to mention is that in amniotes, the way we coupled oxygen and carbon dioxide respiration within the lungs is because we evolved respiration supported by ribs. Like we expand our lungs with our ribs, and that way we can ventilate our lungs more efficiently and also couple both O2 uptake and CO2 release with the lungs. That's one way we went into a very different direction with the respiration. So now the question is, so where do the modern amphibians belong? The Batrachia, the fossil salamanders, and the Caecilians. So hypothesis one, the old hypothesis, is that they are lipospondals. So according to this hypothesis, the ground group plus amphibia is this, and the total pan group, Petrachomorpha, is basically lipospondals. Although there was also popular hypothesis until this species was discovered. It is a Basically, the sauropoid is these guys. Remember, this a subgroup of temnospondyls. There's a rhovoid called Geropetrachus, the frogamander, also a nickname, from the early Permian. It exhibits traits associated with the lizard amphibians, specifically the salamanders and frogs. And also the rhovoids in general also share all the traits like pedicellate teeth, large interpedicoid vacuities, and and also some of them also show metamorphic ontogeny with the loss of scales as adults. So it appears that these guys, these rhovoids, have a lot of things in common with modern amphibians. And also fun trivia, the name Geropetrachus means old or ancient frog in Greek, but Gero is coincidentally the Japanese word that answers the question, what does the frog say? Which in English is ribbit.
It's pretty funny, yeah.
Yeah. So now another hypothesis, the first hypothesis, the hippostondal hypothesis, but another hypothesis then supported by the Geropetrachus, which shows that they are the rhovoid temnospondyls. This remains a very popular hypothesis to this day, but now, according to this hypothesis, the crown group Amphibia is shown here, and the total pan group of Batrachomorpha are basically all temnospondyls. They're all stem lizard amphibians.
All right.
Although that remained the popular hypothesis to this day. Although there was a less popular hypothesis, the polyphyletic hypothesis, which says that the frogs and salamanders belong here, but the Thessalians belong in the Lepospondyls. Although
so they're more separate than the other two. These totally different cousin lines, not close at all.
Exactly. Although it's not a popular hypothesis because this would mean that the Gymnophionia, or the Thessalians, are more closely related to the amniotes than they are to the frogs and salamanders. But we are pretty sure that the Thessalians are more closely related. So this is probably wrong. So according to this, it's not monophyletic, but we are pretty sure that it is monophyletic. So this is why this hypothesis is not popular nowadays. And one of the problems of resolving this controversy is that there's another gap in the fossil record regarding amphibians. Basically, it says that in this region, fossil amphibians are very rare. They're almost non-existent. So this is also one reason why it's very difficult to place them among these groups. So
Okay, you heard a paleontologist, go look up that gap right there. Go see if you can find any areas where amphibians might live in the rocks and get to it.
Mm-hmm.
Well, I'm sure there are amphibian fossils from that gap. It's just they're more rare than they are outside.
They're very rare. Yeah, there are fossils, although most of them are like modern. Like the ones that we know are modern amphibians, and we want to know the stem members of these groups. So the stem, we need more stem members to really confidently link them to the other amphibians that we know of. Yeah. Although there was a recent discovery that. I mentioned it now. The modern most popular hypothesis is this one, the rhovoid hypothesis. But there was a recent discovery of this, a Thessalian-like stereospondyls. Remember that these stereospondyls are these guys right there, stereospondyls. These monstrous, large amphibians are included here. Coolosuchus, one of the last remaining temnospondyls from the Cretaceous is Coolosuchus. Yeah. And this includes this guy recently discovered. It's a chinless goldfish from the late Triassic, described in 2017. A small stereospondyl is interpreted as a stem Thessalian, the next closest relative to Thessalians, or next after the Eothessalia. Like I showed you before, this guy right here, the Eothessalia, I showed you before. So this paper basically argues that this species is the next closest living relative or extinct relative to Thessalians. Yeah. So if this paper is right, then the Thessalians belong all the way over here among the stereospondels. So basically, you have a fourth hypothesis. You have some list amphibians, like the Vargas salamanders, are viscerophoids, and the Thessalians are stereospondels. All the way over here. And there's a neat thing about this hypothesis is because it resolves this otherwise this long gap of Thessalian evolution here. But if you connect them to this group, it's pretty much all resolved. Basically, the relatives are not missing. We have the relatives of Thessalians.
So did this group listen to loud music?
So can you repeat that?
Did this group listen to loud music?
Oh no,
stereo.
Spondels, the name spondel refers to vertebrae. So I think stereo means repeating vertebrae. I think if the name translates to repeating vertebrae, or I don't know exactly what it's referring to, but yeah, it refers to their vertebrae in some way. Yeah.
Is there oh, sorry, go ahead.
Yeah. So, but
you were saying, so what were you saying, Walker?
I'm just curious, is there any time calibrated phylogenies that would support, I don't know, one divergence estimate over another?
I include the time calibrations right here for Petrarchia is this.
Oh yeah, but I meant are there any relatively well supported time calibrated phylogenies from extant species? So mostly molecular phylogeny, but you could also use a total evidence analysis type thing.
I think I could include those. These are the extant time calibrations for the common ancestor of Vargas salamanders lived about between this point and this point, and the common ancestor of all amphibians are around this point and this point. Right.
And
also, so is that including Thessalians as well? Because I'm wondering,
I did not include the time calibration of Thessalians. No, I did not include that.
Yeah. I was just wondering because that would, obviously imply that one divergence estimate's more well supported than another, and that could help you infer which way.
Right.
Yeah. Also, I don't think you mentioned it here or not. Maybe you did. I just can't see it right now. But in between the amphibians and the amniotes, there's another clade. There's a subclade or whatever clade called the reptilomorphs that the amniotes are part of, but they're not part of the amphibian clade. Reptilomorphs, I think they're called.
Yeah. Well, I think this does include stem amniotes because the arrow goes for crown amniotes.
Yeah, right. I stem amniotes lipospondels are stem amniotes according to this phylogeny. Yeah, I've seen recent phylogenies that put lipospondels more closely related to the crown amniotes. Right.
Mm-hmm.
But I remember this hypothesis. According to this hypothesis, the crown group of amphibians is green right here. And the total pen group of Petrarchomorpha is basically includes all temnospondels. But let's moving forward a bit. Hold on. Going forward. So according to this hypothesis, too far. According to this hypothesis, basically the crown group of this amphibia is very broad. It includes most of temnospondels. So most of temnospondels are crown group amphibians.
That's pretty interesting.
And yeah. At least according to this hypothesis, of course. And it's a very intriguing hypothesis, but however, not everyone agrees. I found at least 3 recent papers that highly contest this hypothesis from 2017. This hypothesis was from 2017. Let's see here. Hold on.
And this whole picture right here is pre
from this paper. Yeah.
I mean the whole picture. This whole picture right here is pre dinosaur extinction.
Yes. Although it's the dinosaurs are here in the Mesozoic.
Mm-hmm.
So most of the evolution is before the dinosaurs. Yeah. So yeah, I have this hypothesis. Although it's again highly contested, everyone agrees. So we are done. So although I would say, as a final note, so the controversy is still alive, and we need more fossils to resolve this conflict. It's still very interesting. Interesting. Yeah, interesting history.
We need more Jurassic Park living creatures.
Mm-hmm. Right.
It'd be pretty cool if we could revive like Coolosuchus or something.
Yes, like what happened to the Kermit Clade, or the talking, walking, performing frog Clade.
So yeah, I just under 1 hour and 40 minutes. So sorry for the long talk, but it was very informative, and I hope it was very clear.
Yeah, no, I thought that was great. Thank you.
Yes, more than I knew before.
Yeah, for sure.
So, do we have any?
Any questions?
Does my mic suck that badly?
I was able to understand you fine.
Yeah,
but I mean, there might be some quality drop between here and streaming. I don't know.
Yeah. Let's see. So, anybody have any questions in chat or in house?
I guess between the hypotheses, do you have any that you prescribe to? Like, are there any that you prefer?
Oh yeah, I find the new hypothesis very interesting. Okay. Yeah, that one. But however, again, I saw at least 3 papers contesting it, so it's still being discussed. So yeah.
Of course, yeah.
I think for now the safest way is to maintain the most popular one, like the hypothesis about the zorovoids.
Mm-hmm.
I showed. I think that's hypothesis 2, the most popular one. Yeah.
So
I think the new hypothesis has some job to do to contest that. Yeah.
So probably, if I remember the correctly, give or take, most of the amphibian lines died during the Permian extinction.
Oh yeah. Oh, I maybe should have. Can I bring back my slides? I don't know. I closed my slides down. Why did I not do that? I can bring it back. But yeah, I think most of them died at the end of the Permian. Although, as you can see, like I mentioned these stereospondylus.
Yeah.
And those many of those survived, even if they are not related to modern amphibians, they still survived until the Cretaceous at least. Let's see here.
Of course, they did survive. Probably the Jurassic, and then later the asteroid knocked the rest of them out. I'm guessing. Like, you survived.
I think the stereospondylus actually died out before the end of the Cretaceous. Mm-hmm. Like I will show it again.
Yeah,
there we go.
Obviously.
Coolosuchus, you can see Coolosuchus, the last surviving stereospondylus.
Mm-hmm. And it died out.
Unless Thessalians are stereospondylus, assuming they are not, assuming Thessalians are not stereospondylus, the Coolosuchus is the last surviving stereospondyle, and it lived like in the middle of the Cretaceous.
Yeah. Cool. Another thing, an interesting thing about Coolosuchus, the reason it's called Coolosuchus is because it was found on Antarctica.
Right, exactly.
Yeah, that's where the Coolosuchus comes from.
Yeah.
Back
it probably could have survived until that time, because at that place in Antarctica there wasn't a competition between crocodiles.
Yeah.
So yeah.
Yeah, it was. I mean, I can't. Yeah. Well, also, like we were talking about earlier, amphibians are generally better at surviving in colder weather. And so, like, while the Antarctica wasn't as cold as it is today, you didn't have the circumpolar, like, whatever it is that keeps it cold. It was also a little further north.
Yeah.
It was more like Alaska. But, like, you probably couldn't even have crocodilians surviving on that continent because it would still probably be too cold for them.
I think it was probably pretty temperate during the summer, but it maybe have like a very very cold few months in the winter.
Yeah. I mean, Alaska gets pretty warm.
Yeah, right. Yeah. Exactly.
Like Alaska, Canada is probably analogous,
Mm-hmm. Also, I think if you have seen the old Walking with Dinosaurs series, I think there was one episode that showcased Koolasuchus as well.
Yeah, I haven't seen that in a long time. Mm-hmm. I more recently saw the Walking with Beasts, the Walking with Monsters.
That was good.
Do you have any comments from the live chat?
Yeah. So, Bede, Eddie, you have any questions about what we saw? Besides the microphone questions?
Well, sorry about my mic. I don't have a high quality mic. I'm using the internal mic from my laptop. So
I remember those days.
Mm-hmm.
We're using an internal mic from the laptop and the Wi-Fi from McDonald's to stream. But while we're waiting for questions, Walker, what's up with what?
If there are no questions from the live chat, then I think I will go to bed soon. We are now at 1 hour and 40 minutes, but I'm still open for a few questions. If Walker has a few questions, go ahead.
No, like I said, I've been asking my questions as I went for the most part. So I don't.
Me too. Pretty much. If other questions, I'll probably remember later and put it in the comments, whatever. But anyway, So what's up? So before you go to bed, Ness, what's anything coming up on your channel or that you're doing anything big?
My channel is just it's like a zombie. Sometimes I will publish videos, but most of the time I don't have anything planned for anything basically. But the Jackson Reed's channel still keeps rolling with his videos. So if you want to support my work, I help Jackson Reed always. Yeah.
What about you, Walker? Anything coming up in your life or channel that you want to?
I mean, your channel's still probably more active than mine. I haven't published anything in like a very long time, over a year, I think. I mean, YouTube's sort of just taken a back seat because I've gotten really involved in research, like doing.
So what are you researching now? You talk about it, or is it?
I could briefly. I mean, I won't go into too much depth because I also probably need to go to bed. But like I said, I do computational phylogenetics. Specifically, I work in a methods lab. So what we work on is developing phylogenetic methods for other scientists to use.
All right. Yeah. Cool. Awesome. Can't wait to see your papers talked about in a future episode.
Yeah, hopefully I have one. I have one in the works right now, so that'd be pretty sick if I got published by the end of the semester.
Oh, peer reviewed Walker.
Yeah,
coming soon.
Yeah, I haven't submitted it for review yet, but yeah, we'll see. We'll see.
As for me, before we go, next episode probably going to be talking about the 7 kingdoms of the pre-England Anglo-Saxon kingdoms.
Oh, that sounds interesting.
With my good friend B.
Who will be the speaker?
Who? What now?
Who will be the speaker of that 7 kingdoms talk?
This guy, the non-binary Bede, formerly the venerable Bede.
More. Very cool.
More.
Yep. I think it's not this Saturday, but next Saturday that he will be speaking. Give or take any emergencies that might happen. But until then, thank you both for being here. Thank you for teaching us new things.
Yeah, of course. Thank you so much for having us.
It's a pleasure.
And as always, never stop learning. Enjoy the randomness. I'll see you next time. Bye.
All right. See ya.